All right, this is going to be our walkthrough for the homework assignment titled Trapezoidal Sum Approximations. And so we're just going to use a trapezoidal approximation with the number of subintervals given to approximate the area under the curve on the interval from 0 to 4. So that's what this integral is where the integral represents the exact area under the curve. And so we're just going to use the trapezoidal approximation to approximate this integral, right? And so we need to know that our trapezoidal approximation, when we have equal subintervals, is the formula b minus a over n divided by 2 times y naught plus 2y1 plus 2y2, and so on, down to 2y sub n minus 1 plus just y sub n. And so that's our trapezoidal approximation formula. And so in order to figure out what this is for this particular function, well, we just need to do, first of all, b minus a over n. So that'll be 4 minus 0, right, because our a and our b values are 0 and 4, divided by our number of subintervals, which is 4. So that gives us 1. So in the front here, we're going to have our trapezoidal approximation is equal to 1 over 2, 1/2. Right? Get rid of that little dot there. 1/2 of our first y value. So the y value at our initial point is at 0. So that's going to be 0 cubed. And then it's going to be plus 2 times 1 cubed. And then plus 2 times 2 cubed. And then plus 2 times 3 cubed. And then the last one will just be plus 4 cubed. Right? Because the last piece of our formula doesn't involve being multiplied by 2. And so we just end up with 1/2. Well, 0 cubed is 0. 2 times 1 cubed is 2. 2 times 2 cubed, 2 cubed is 8, so that'd be 16 when you multiply by 2. 3 cubed is 27. Right, so when you multiply 27 by 2, you get 54. And 4 cubed is 64. Add those all together and divide by 2. And you end up getting 68. For our second one here, we're going to take the integral from 0 to pi, so that interval, 0 to pi, and divide it up into 4 subintervals. So that'll be b minus a will be pi minus 0 divided by the number of subintervals. So pi over 4 is the length of each subinterval. That's the b minus a over n. So our trapezoidal approximation should be that value, which sometimes I refer to as h, or b minus a over n, divided by 2, times the initial y value. And our initial y value is just going to be the sign at 0. And then it'll be plus 2 times the sign of pi over 4, right? Because if the intervals are of length pi over 4, if we start at 0, the next one should be pi over 4. So plus 2 times the sign of pi over 2. And then plus 2 times the sign of 3 pi over 4, and then plus just the sign at the end, the sign of just pi. And so what we've got here is just pi over 8, right? Half of pi over 4 would be pi over 8. Sign of 0 is 0, and the sign of pi is also 0. And so those two are going to go away. The sign of pi over 4 is root 2 over 2, so that's 2 root 2 over 2's. The sign of pi over 2 is 1, so that's just 2 in the middle. You multiply by 2. And the sign of 3 pi over 4 is also root 2 over 2, so that's 2 root 2 over 2's. So it looks like we have pi over 8 times 2 root 2 over 2, which is root 2, plus another root 2 at the end, right? This is root 2 and this is root 2, so that's 2 root 2. So it's times 2 plus 2 root 2. And of course, that answer is a perfectly acceptable answer. If you want to distribute the pi over 8 through, you can. Like, I'll take this answer. But if you distribute the pi over 8 through, you'll end up with pi over 4 plus pi root 2 over 4. You could also write it as pi times 1 plus root 2 all over 4. Lots of different ways to write the answer, but any of them are fine. All right, for our next one here, we're looking at the interval from 2 to 5. So when we do our trapezoidal sum, I'm just going to do it right here this time. It'll be b minus a over n. And then, of course, that value is always divided by 2 when we have our equal subintervals here. And so then we'll do the first y value, which will be the value of this at 2. So that'll be 2 over 2 minus 1. And then plus 2 times the value at 3, right? Because if we have 3 subintervals and the length is 3, each one is a width of 1. So the next one's going to be this at 3. So 3 over 3 minus 1. And then plus 2 times 4 over 4 minus 1. And then plus just 5 over 5 minus 1. And so out in the front, we just end up with 1/2. Right, so we've got 1/2 there. 2 over 2 minus 1 is just 2. Right, 2 over 1. And then we've got 3 minus 1 over here, and the denominator is a 2. That cancels with this 2, so that's just plus 3. And then we've got 2 times 4/3, so that'd be plus 8/3. And then we've got plus 5/4. So it looks like within there, the common denominator is going to be 12. Right? And so we'll have 24/12 plus 36/12 plus 32/12 plus 15/12. So that adds up to be 107/12, which gives us 107 over 24 when we multiply by that 1/2. All right, for our next one here, this time we don't have the actual function. We just have a chart of the values. And so what we want to do is we want to look at that chart and see if we have equal subintervals. And so, or if we can create equal subintervals using the chart. And we have the values at 1, 2, 3, 4, 5, 6, and 7. And if we're doing from 1 to 7 with 3 subintervals, then we most definitely can make equal subintervals of that, right? 7 minus 1 divided by 3 is just 2, right? So like each subinterval is going to be 2 units long, right? And so I do know the value of my function in each of those values. So even though I'm given a chart, I can still use the trapezoidal formula. And I'm going to do that b minus a, I'll write it out again, b minus a over n divided by 2. And then we'll do the first y value, which is the y value at the start of my subinterval, that's 1, plus 2 times the y value at the end of the first and beginning of the second subinterval, so that's 2 times 4. And then 2 times, this one will just be 0. And then the last one, again, because it's only used as the end of that last interval, it's not used for the start of another one, it's just one of those. And so we had 7 minus 1 over 3, which was 2, and then 2 divided by 2 is just 1. So we just end up with 1 plus 8 plus 6, which is just 15. All right, and for our last one here, we're looking to evaluate from -1 to 7 with 4 subintervals. Well, that'd be 7 minus -1 over 4, which is 8 over 4, which would just be 2. So if I have the values every 2 units, I can use the formula. But from -1 to 2 is 3, right? And this one's 2, this one's 1, and this one's 2. So I don't actually have equal subintervals each time. And so I can't use the formula. I just have to come up with different trapezoids for each one. So the way I'm going to do this is I'll take the first subinterval here to be from -1 to 2. And so the way that we'll do this is the area of the trapezoid should be the first base plus the second base, so 3 plus 4 divided by 2, and then times the width of that subinterval, right? From -1 to 2 is 3. And we'll do the same for the next. Now we're going to do 4 to 6, so 4 plus 6 over 2, and then times the length of the subinterval from 2 to 4, which is 2. And then we'll do this next one, right? 6 plus 2 divided by 2 times the length of that subinterval, which is just 1. And then we'll do 2 plus 10 divided by 2, that's this one, times the length of that subinterval from 5 to 7 is just 2. So Some of these are going to simplify out nicely, like those 2's will cancel, those 2's will cancel. Here we've got 7 over 2 times 3, that's going to be 21 over 2. And then plus 10, and then that one's going to be 8 over 2, which is just 4. And then that last one is just going to be 12. So it looks like we've got 21 halves plus 10 plus 4 plus 12. Well, 10 and 4 and 12 is 26, which is 52 halves plus 21 halves would be 73 halves. And that's the end of the walkthrough for this trapezoidal sum approximation assignment.